Now let's look at the connection between the LCM and the GCF. They're connected by the following formula. The LCM is the product between the two numbers divided by the GCF of the two numbers. Now, it's only good if you have two numbers, of course, but say, for instance, you have this information ahead of time, like someone asked you to find the GCF, then you don't have to go through all the same trouble to find the LCM. You can just plug into this formula. So let's say we've already found the GCF of these numbers, and we've already found the product of these numbers. So then we can quickly get the LCM by dividing. So between 35 and 60, what we need to do is take this 2100, which is the product, and divide it by 5. What we get there would be 420. That'll be the LCM between those two numbers. Now let's move on to the next one. Just divide. So between 72 and 126, take 9072 and divide it by 18. Okay. And then for the last one, take a between 280 and 360, we just need to take 100,800 and divide it by 40. I'll let you find those on your own, but that method is great for finding the LCM if somebody already gives you the GCF, or maybe you've already found the GCF. This formula connects them. Basically, the product, if you were to multiply this formula by the GCF, the product of the LCM and the GCF is equal to the product of the numbers. Okay, great. The next slide, we'll look at another way to find them together using a Venn diagram. So what we'll do is we'll put the primes. We'll first find a prime factorization, and then we'll put them in a Venn diagram with one circle for each of the different numbers. And then the intersection between the numbers gives the GCF, and the union between the sets gives the LCM. So let's say that we've already found the prime factorization of these numbers. So 12 is 2 squared times 3, and 18 is 2 times 3 squared. So we go do the Venn diagram. We have a circle for 12 and a circle for 18. They share a 2 and they share a 3. Now 18 has an extra 3 and 12 has an extra 2. The intersection is the GCF. That's going to be 6. The union is the LCM. That's going to be 36. 2 times 2 times 3 times 3. Okay, great. And so now let's do it for the next one. So we have 27 and 36. We found a prime factorization of these guys. We have 27 is 3 cubed. 36 is 2 squared times 3 squared. Circle for 27. Circle for 36. They share 2 of the 3's. 27 has an extra 3. And 36 has 2's that the 27 doesn't have. 2 of them. Intersection is GCF. which would be 9. Union is the LCM. Just multiply the numbers that are there, and that'll be 108. It's 27, 3, 3, and 3 times 4. 2 and 2. I think that's 108. Yeah. All right, great. And then the last one is just 54 and 72. So 54 is 2 times 3 cubed, and 72 is 2 cubed times 3 squared. Circle for 54. Circle for 72. They share a 2. And they share 2 to 3's. 54 has an extra 3. 72 has 2 more 2's. The intersection is the GCF, 18. The union is the LCM. And that's going to be 3 2's and 3 3's. 8 times 27. Which is 216. Great. Finally, let's look at word problems that involve the GCF and the LCM. What you should do basically is read through the problem, and as you read through, if you find yourself looking for how many objects will there be in each group, if each group contains the same number, then that's going to be GCF. If you find yourself looking for when will 2 events occur at the same time, that's going to be LCM. Okay. The first problem. Well, another way to do it would be if you find numbers in the problem and the thing that you're looking for, if you feel is greater than the numbers in the problem, then that's the LCM. But if the thing you're looking for is smaller than the numbers in the problem, then you're GCF. Let's read through the problem. We have Whitney and Kim. They're in a bicycle race, going around a track, starting at the same place, traveling in the same direction. Whitney is going slower than Kim. Whitney's doing a revolution in 40 seconds. Kim is doing a revolution in 45 seconds. How long will it take before they reach a starting point again simultaneously? So we see the numbers in the problem are 40 and 45. It's going to take longer than that for them to be simultaneously at the starting point again. The thing that we're looking for is greater than the numbers that are in the problem. We're trying to see when will 2 events occur at the same time. And so we're going to try to find the LCM using whatever method. 40 is 8 times 5, so it's 2 cubed times 5, and 45 is 3 squared times 5. LCM, we take all the primes that are there, so we take a 2, a 3, and a 5. When it comes to exponents, we take the greatest amount on each. So we got a 3 there on the 2. We have a 2 on the 3. And the 5 just gets a 1. And then the LCM would be this product, which is 72 times 5. So it's going to take 360 seconds until they are back at the starting point simultaneously. 6 minutes. The next problem says this person, Terry, is cutting. They have two pieces of 2x4s. One is 60 inches long and one is 72 inches long. And they're going to cut it so that it's going to be in shorter pieces. If they do this, and they all must be the same length, then what's the longest that the shorter pieces could be? And we don't want any leftovers. So the numbers in the problem are 60 and 72. The thing that we're looking for would be shorter than that. We're cutting these in pieces. And so then we're looking for the GCF. Let's try this by the dividing method. We have 60, we have 72. We can divide by 2 and get 30 and 36. Divide by 2, get 15 and 18. Divide by 3, get 5 and 6, sorry. And now they don't share anything in common, so the GCF then would be 12. They'll be 12 inches long. That's the once they cut them all down. This guy will have 5 of them. This guy will have 6 of them. Altogether, Terry will have 11 12-inch 2x4s. Okay, great. And so that's the connections between LCM and GCF.